Today we will discuss another problem, Hamiltonian cycle, and we solve this problem using backtracking algorithm. Before solving this problem or discussing what is Hamiltonian cycle, few definitions are required for a given graph. So first I will give these definitions. Okay. So here for all the definition, a graph G V E with n vertices is given. Okay. So for all these definitions, we are considering a graph. Graph can be directed or undirected, but graph should be connected. Okay. So here graph with n number of vertices is given. So the first is walk. First definition is walk. We define what is walk. Here a walk in G is an alternating sequence of vertices and edges beginning and ending with vertices such that each edge is incident on vertices. Each edge is incident on vertices preceding each edge E is incident on vertices preceding and following E. Okay. Now, see what is walk for a given graph G with n number of vertices. A walk in G is an alternating sequence of vertices and edges. That walk begins with vertex and end with vertex. And here each edge incident on vertices preceding and following that particular edge. Now see, this is the example graph G1. Okay, so here what is the meaning of walk? Walk means simply traversal of graph, and the walk can start from any vertex. So here this is the graph. The walk can, according to the definition of walk, if the walk can be started from 1, 2, 3, 4, 5 or any of the vertex. Okay, so simply you consider walk as a simple traversal without any restriction. Without any restriction means here edge can be repeated or vertex can be repeated. Okay, so suppose I'm just taking one walk, see 1, and then 1 is the vertex for the given graph G1. For the given graph G1, here just the one walk is W1. W1 is, if I will start from 1, then followed the edge B, 2, and then C, 3, G, 5, and 4, H, 4, F, 3, E, 1. This is one walk. Here see the walk 1. This is the one vertex. This is the edge 1, B, 2. So here just 1 to 2, 1 to 2, 2 to 3, 3 to 5, 5 to 4, 4 to 3, 3 to 1. And here see what it is given. A walk in G is an alternating sequence of vertices and edges. So this is a vertex, this is edge, this is a vertex, this is edge, this is a vertex, this is the edge. Okay, and beginning and ending with vertex. Every walk should start from a vertex and end at a vertex. Suppose for this graph, for the same graph G1, another walk can be like 4 F3 C2. This is also a valid walk. The second walk here, it starts at the vertex 4. See, this is the walk 4 to 3, 3 to 2. So here simply just the vertex 4, it will start from 4 and end from 2, and the next one is each edge is incident on vertices. Like here we consider the edge F. So F is edge incident on vertices that precedes and following F. So F is a edge that is incident on 4 and 3. That is, it is written each edge E is incident on vertices preceding and following E. Okay. Now another walk we can consider, we can write for this graph is say 4 F 4 F 3 C 2 E 4 H 5 G 3. See here, this is the another walk 4 F 3 C 2 E 4 H 5 G 3. Okay, and here again we can write 3. In this walk there is no restriction. See, restriction means in the walk edge can be repeated or vertex can be repeated. If we consider this particular walk, okay, so see 1 B 2 C 3 G 5 H 4 F 3 E 1. So here see, this is 3 vertex is repeated. 1 B 2 C. The same here, the 1 is repeated. There is no vertex, no edge is repeating. Here 4 and again the 3 vertex is repeated. Okay, so suppose just for the same graph we am writing the walk as 3 G 5 H 4 F 3 G 5 H in this way. See here the edges and vertices both are repeated. See, for this walk number 4, the vertex is 3 and this 3, the vertex 5 and 5, the edge H. Okay, so the walk is simply the traversal. It can start from any vertex. It can start from any vertex and ends at any vertex. There is no restriction. We can traverse the graph in any way. And the second, here in walk, edge can be repeated or the vertices can also be repeated. Okay, so here just I have written the walk as an alternating sequence of vertices and edges, that every walk should start from a vertex and ends at a vertex. Okay, here just see, just this walk, correct it, 5H, just it will not end at the 5H4, just always, just here it starts at a vertex and ends at vertex. Okay, I have not written 4, so just you correct it. This is 4. Okay. Now the walk, sometimes walk is also written as the sequence of vertices only. We do not write age. Like we can write the walk W1 in this way also. W1 is, walk W1 is this one. 1, 2, 3, 5, 4, 3, 1. See, just 1, 2, 3, 5, 4, 3, 1. Okay. So here we can write walk as an alternating sequence of vertices and edges, or we can simply give the definition of walk as walk is a sequence of vertices. Sequence of vertices. But in this case, when we are giving the definition, the other definition, or we can write walk is a sequence. Walk is sequence of vertices. Sequence of vertices like V1, V2, so on, Vk. K is greater than or equal to 1, less than or equal to n, where such that Vi is adjacent. Vi is adjacent to Vi plus 1 for every I greater than, I is greater than 1, less than or equal to k minus 1. See, this is another, sometimes in the short form we avoid writing the ages. So walk is a sequence of vertices V1, V2, so on, Vk, where k is from 1 to, k is varying from 1 to n, such that Vi here, just when we are writing, like see, consider here this definition, 1, 2, 3, 5, 4, 3, 1. Just here the W1 is what? 1, 2, 3, 5, 4, 3, 1. So what this definition tells, that the walk is a sequence of vertices V1, V2, so on, Vk, such that Vi is adjacent to Vi plus 1. See, for the graph, 1 is adjacent to 2, 2 is adjacent to 3, 3 is adjacent to 5, 5 is adjacent to 4, 4 is adjacent to 3, and 3 is adjacent to 1. What is the adjacency means? Here V is adjacent to Vi plus 1, that is age Vi plus 1 belongs to E. For every I is greater than 1, less than or equal to k minus 1. Okay. So in this way, the walk can be written in two ways, either the alternating sequence of vertices and edges, where the walk begins and ends at a vertex, or the walk can be written as only the sequence of vertices. But remember that here, in the case of walk, what you have to note down, age can be repeated and vertices can be repeated. See here, just 1, 1. In this case, if we write W2, so we can write W2 in this way also, 4, 3, 2. Okay? W3 can be written as 4, 3, 2, 4, 5, 3. Okay? So here, if we write only, then simply the vertices can be repeated. Okay, so if we are repeating the vertex, then age automatically repeated. On W4 can be written as what? 3, 5, 4, 3, 5, 4, 3, 5, 4. Okay, so here what is it? If you consider this representation where the walk you represent walk as a alternating sequence of vertices and edges. So edge can be repeated and vertex can be repeated. If you are using this one, then the vertex can be repeated. This is the definition of walk or simple walk. Okay? Now the next is what? The definition is closed walk. Okay, just here I am changing in the same, just you note down the closed walk. Okay, so closed walk is a walk in G is an alternating sequence of vertices and edges beginning and vertices such that each edge is incident on vertices preceding and following each. This is the definition of walk. When we say that closed walk, okay, so what is closed walk? A closed walk is a walk with start and end vertices are same. Closed means that the walk will start from the same vertex where it ends. Means start and end vertices are same. If in a walk the start and end vertices are same, then the corresponding walk will be what? The closed walk. Okay, so here if we follow this sequence in the second definition, and the walk is what? Walk is sequence of vertices v1, v2, so on, vk. I is greater than or equal to 1, less than or equal to n, then v1 equal to vk. v1 and vk, this is what? The first vertex, start vertex, and the end vertex. So if in any walk start vertex and end vertex are same, then the corresponding walk is called closed walk. Okay, so see here, this walk is a closed walk because it starts at vertex 1 and ends at vertex 1. This is not a closed walk because it starts at 4 and ends at 2. This is not closed walk. 3, 5, 4, 3, 5, 4. 4, and suppose here we write 3 again. See, 3, 5, 4, 3, 5, 4, 3. So this is what? Closed walk. So W4 is a closed walk as the start and end vertices are same. W1 is a closed walk. So simply you understand what is walk. Walk is simply traversal of graph, we can say. It can start from any vertex and end at any vertex. But if the start and end vertices are same, then the corresponding walk is called closed walk. Okay. Now after walk, just here again I am saying, when we talk about the walk, then there is no restriction. Note down, no restriction means the vertices can be repeated. If you are considering this representation, vertices can be repeated, edge can be repeated. Okay, so carefully note down, in the walk में कोई भी रिस्ट्रिक्शन नहीं है. एज भी रिपीट हो सकती है और वर्टेक्स भी रिपीट हो सकती है. ठीक है. सो walk, no restriction. ठीक है. What is the meaning of no restriction? Age can be repeated. If we are representing walk in this, and the vertex, edges can be repeated and vertices can be repeated. Okay, this is walk. Okay, now come to the another definition, that is trail. So just previously I can see walk and closed walk. Okay, so now we consider the trail. Trail is a walk, but some restriction. What is trail? Trail in G is a walk. Trail in G is a walk with no age is repeated. Okay? So, in a walk, if we consider the restriction that no age is repeated, then the corresponding walk is called trail. Okay? So, when we traverse a graph and if any age is repeated, then particular walk is not trail, because in the walk there is no restriction, but in the trail there is a restriction that age cannot be repeated. Okay, so age repeat nahi ho sakti hai, theek hai. So just these are the walks. Now see whether it is trail or not. Okay, so here see 1 B 2 C 3 G 5 H 4 F 3 E 1 है. See यहाँ से देखो आप, यहाँ से 1 B 2 C 3 G 5 H 4 F 3 E 1. There is no repetition of age, but here see vertices are repeating. Just 3 is repeated, but age is not repeating. Okay? So this walk is a trail. This walk is trail. Now consider this walk. This walk is also a trail. Okay? Now consider W3. W3 is 4 F 3 C 2 E 4 H 5 G 3. Okay, so here F C E H G, again no age is repeating, so this is again a trail. Now consider the walk W4 3 3 G 5 H 4 F 3 G 5 H 4. So here see the age, what age? G, and this age G. Okay, so here the age, this age is repeating, so W4 is not trail. This is walk, but it is not trail. This is walk as well as trail. This is walk as well as trail. This is walk F C E H G. No age is repeating, but here W4 is not trail. Another example of walk that is not trail, say suppose trail, suppose W5. If you write W5 in this way, say 2 C 3 F 4 E 2 C 3 G 5. Okay, so here C, age C is repeating. Okay, so this again, this walk is not trail. Okay, so see, this is definition of trail, where where there is no repetition of ages. Okay, like closed walk, there is the same concept, the closed trail. Closed trail. What is closed trail? The closed trail is the same. The closed trail, it is closed trail. It is closed walk with no age repetition. Okay? So this closed trail is a closed walk with the restriction that no age is repeated. Okay, so here when the, say suppose this one, this walk is a closed walk, as there is no age is repeating and the first vertex and the last vertex is same, so this is trail as well as it is closed trail. Okay. Now the another definition is path. Okay. So here come to the path. Okay. What is path? Path, again there is a restriction on path. Path is a trail. Path is a walk. You can say path is a trail, you say in the same way. Path is a trail with no vertex is repeated. Okay. So here just path is a trail with no vertex is repeated. Clearly understand if the edge, if there is no edge repetition, then the vertex can be repeated. But if the vertex is not repeated, then edge cannot be repeated, as the definition of the edge, that edge is incident on vertices. Okay, so if I am imposing the condition that no vertex is repeated, if the no vertex is repeated, it means the edge cannot be repeated. Okay, so see here, just what walk are, say suppose this W1 is a walk as well as trail. Now see whether this W1 is path or not. 1, 2, 3, 5, 4, 3. Here see the vertex 3 is repeated. So simply just the path means all the vertex should be distinct. Okay, so here the vertices should be distinct. So this walk W1 is what? Not path. This is not path, as here the vertex 3 is repeated. W2 is a walk as well as it is trail as well as it is path, as no vertex is repeated here. W3 4, 3, 2, 5, 4, 5, 3. Here again the vertex 3. See here 4, 3, 2, 4, 3, 2, 4, 5, 3. So here see just 2 vertex are repeating, 4, 4 and this 3, 3. So again W3 is not path. W3 is not path, whereas W3 is trail, but it is not path, as the vertex is, there is a repetition of vertices. Okay. Now this you can see the same here in this graph now. But before this definition, again consider here one more, closed path. Closed path. Okay. Closed path is a trail with closed path is a closed trail. Closed path is a closed trail with no vertex is repeated. No vertex is repeated. Okay. So closed path means, again the closed path means no vertex is repeated, as it is path. Path means no vertex, all the vertices are distinct. But if it is closed, wherever there is a word closed, it means the first vertex and the last vertex is same. It will start from the vertex and ends at the same vertex. Okay. So here W1 is not path, W2 is not a closed path, W3 is also not closed path, and W3 is even not path. W4 is also not path, and W5, if it is not trail, then it is not path, because we are adding one more restriction in trail. Okay. So simply just if we consider the closed path, then we write in this way. Suppose the path P1 is, say suppose path P1 for the graph G1, we can write like 4, 3, 2, 1, 4. This is closed path. It will start from 4 and ends at 4, but there is no repetition of vertex. Other than start and end vertices, no vertex have been repeated in the path. All the vertices other than start and end vertices, all the vertices should be distinct. That is called path. Okay. So here now just I have given the definition of walk. Walk is simply the sequence of vertices without any restriction. Okay. Now the closed, wherever we are having the word closed, means start and end vertices are same. After that I have given the definition of trail. Trail is a walk with one restriction, that edge cannot be repeated, but the vertex can be repeated. Okay. So here if we impose one restriction, that edge cannot be repeated in walk, the corresponding walk will become trail. And the closed trail, the same, first and start vertex are same. Okay, with no edge is repeated. Now come to the path. Path is trail with one more restriction, that no vertex is repeated. If the vertex is not repeating, then there is no question of repetition of edges, as the definition that edge incident on vertices. Say this edge is incident on vertices. So if I am saying that edge is, vertex is not repeated. If the vertex is not repeated, then edge cannot be repeated. But the other is possible, that edge is not repeated, but the vertex can be repeated. Okay. So and the path. Path is simply the trail with two restriction. With the trail means no vertex is repeated. Okay. So this is the definition of walk, trail and path. Now when we say that, what, just